Alright, this video is going to be an attempt to explain how a drill bank is set up and how to create a post processor for it. So here's an example of a drill bank. It's a little unusual that it is not using binary numbers, but it is using tool numbers instead of the binary. So we're going to go through and look at how this is set up. So there is 5 and 5 is the drill bank. So we have 5 drills in the X and then 5 drills in the Y. The X is T21 through 25, and then in the Y it's 25 through 29. The first step is creating the drill bank layout. So this is the XML file that's located in the post folder. We have the value of where the first drill is supposed to be, or is, and that is 0, 0 location, and that is the point and position of T21. Then the next in the list, we have drill bank again, that is now has a value of 1.2598, which is the imperial equivalent of 32 millimeters, specifying the tool diameter. Then if this drill bank is operating in a binary, we'd also have the binary number. In this case, we have T22, and we will continue on down this list until we fill in all of the X values until we get to T25. Then we're going to work in the Y direction. So T26, we should probably have an offset here in the X direction of 5, because that is the distance that we are off from the primary indexed drill. And working our way again down through the list in the Y, because we can see the top ones were the X, the bottom ones here are the Y. In 26, we actually do not need it to be 0, 0 here. So we're going to modify and remove this section. So we are actually now 26, 27, 28, and 29. So this now matches up to the image that we have here, where drill T26 is in the Y direction, and that is the offset from the primary T21. That is where the location of T26 is located. So 25 is a shared in the Y and the X. So once that file has been created, we'll click Save. Then we need to take a look at the scripting. Now, before we look at the post in the script, we have to understand what whole sets are, or what the whole set count is. So if we look at an image of a basic cabinet side, some drilling in it, the rectangles are indicating each whole set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a total of 10 whole sets. Within each whole set, we have a set of holes. So whole set number 1 here in the upper left has a set of 2 holes within that set. Then the larger whole sets have a total of 5 in each one. And again, a couple balances here with a whole set with 2 holes within each set. So now we'll take a look at the script and how we loop through this whole set. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 whole sets. The value that we're getting right here with the function drill get whole sheets count with the sheet number. The sheet number is coming within the drill bank subroutine. This is going to return how many whole sets we have on the sheet. Then, as we loop through here, we are going to loop through this hole set count from 0 to maximum hole sets. Then farther down, we are going to loop through each hole within that set. So for this particular file, we're first setting up for the beginning of the file. So previous drill is equal to nothing. It's not set yet. So it is not going to be equal to the drill number. The drill number in this case is the binary number that we just saw in the value in our drill bank setup. It is not equal, previous drill is not equal to what we've just collected here. So we are going to go into adding code to the beginning of the file. So this is adding the drill name to the file. The drill name is being derived from the name that we have in our drill file in order that they are entered in. And it is collecting that and building a string of the tool names. Then we're going through adding that drill name to the file, the G43H. I will explain this replace in just a minute. And then we have an M3. So let's take a look at what that has been produced by this post processor and compare the two side by side. So this section of code that we have right here is coming from this section here. And really it's just right here. So we have the M70. We have the M70 that is located right here. That matches up to the M70 on line number 5. Then we're collecting the tool name and building the string for the tool name that is then going to be added to the file right here, which is these two commands here. That is T21 and T22. That is what would be drilling the two holes in the hole set that we have right here. Then we are collecting and getting G43 with the height offset. The height offset is the first drill that is being used without the tool number, without the letter T. And that is what this replace is doing. It is replacing the T in the first drill with nothing. So that is how we're getting the 21 from the T21. After that is entered, we have the M33 that is being added to the file. Then we're getting down into the motion of the file and actually determining where that drill needs to be located. We are getting the hole X and the hole Y that is getting placed in here. The Z value is getting put in by the safe Z variable. Then it continues to loop through all of the hole sets. And as we see in the next loop, we have another M70, which is here on line 78, collecting all of the tool names again through the little for loop that we have right here, getting the number of holes in each of the hole sets, or getting the number of holes within that set, putting in the drill name, adding to the file. This is just the string builder. Then again, the G43H, and this is located here with the T21. And we can see this is using drill 21, 22, 23, 24, and 25. That is a total of 5 holes that is creating the hole set here. And since the file is not changed, or the number of drills have not changed, this next series of commands here is going through the process of drilling all the holes within that series or within that line for the 5 drills that have the 5 hole sets. Then we get down to here, we see that that drill number has changed, or the orientation of that drill number has changed from 5 drills to a total of 2, and just continue to loop through this file and loop through all of the hole sets. Hopefully this helps explain how a drill bank script is set up. It is a little bit difficult at first, but once you understand how everything is entered in here and you're able to see the effects of what is entered in and compare it to the file, hopefully this is of some help.